We will use some online molecular modeling to help us understand the significance of the zigzag representation in bond line drawings for alkanes. On the left-hand side of the screen, the molecular editor is used to draw a two-dimensional bond line representation of ethane. On the right-hand side, a ball and stick representation in 3 dimensions is produced almost instantaneously. Recall that the ball and stick representation reflects more accurately the tetrahedral geometry about the carbons. In terms of the bond line drawing, if we now add another carbon to make propane, clearly a bend in the structure is required at the point where the blue square is shown. Otherwise, the presence of a carbon would not be indicated. But beyond this practical requirement, there are other reasons for drawing the zigzag representation as we do. Let us add one more carbon to make butane. Now we can reorient the ball and stick model so that it is aligned with the bond line drawing. Red dashed arrows are drawn to bring to our attention that the carbon-carbon-carbon bond angle is essentially the same in the ball and stick representation and in the bond line drawing, and of course should be about 109.5 degrees. In other words, the zigzag is in fact representing 2 dimensions of the carbon atom's tetrahedral geometry. And of course, a tetrahedral geometry can be built off of a carbon in the zigzag representation by adding wedges and dashes. Here we show adding a wedge. But there is still more to the zigzag representation than being consistent with the carbon's tetrahedral geometry. We will go to a different molecular visualization tool to explore this next point. Once again, here is the ball and stick model for butane. Because carbon atoms are bonded by sigma bonds, rotation about the bonds can occur, and in fact, occur very rapidly at room temperature. We call these different orientations, which result from the rotation about sigma bonds, conformers. Notice that in each conformer, the tetrahedral geometry about each of the carbon atoms is maintained. So, while the zigzag representation in bond line drawings is consistent with the tetrahedral geometry, other representations are also consistent. So what is so special about the zigzag? As it turns out, the zigzag representation is also consistent with a molecule's most stable or lowest energy conformer. To see this, it is helpful to compare this conformer, which is consistent with the bond line drawing, to this non-zigzag conformer. Hopefully you can see in this second conformer that the methyl groups on the ends of the chain are brought closer together, and as a result experience some crowding or destabilization. On the other hand, the zigzag conformer have all the atoms in the molecule spread out or separated as much as possible. In summary, why do we write straight chain alkanes in a zigzag fashion when we represent them as bond line structures on a two-dimensional surface? It is because the zigzag allows for a clear indication of each carbon atom, is consistent with the carbon atom's tetrahedral geometry, and is consistent with a molecule's most stable conformer.